Welcome back. In this video, I'll be solving Leetcode problem 124 binary tree maximum path sum. A path in a binary tree is a sequence of nodes where each pair of adjacent nodes in the sequence has an edge connecting them. A node can only appear in the sequence at most once. Note that the path does not need to pass through the root. The path sum of path is the sum of the nodes values in the path. Given the root of a binary tree, return a maximum path sum of any non-empty path. So we have non-empty path, and we need to find the maximum path sum. So not necessarily goes through the root, as you can see here. An example maximum here would be this. So let's see. Okay, so there are a lot of nodes. We cannot do n squared. And since the values are negative, that makes it a bit more complicated. But this is something we can solve with a recursion. So we'll just go and call, if the node doesn't exist, let's just do the auto and then we just return 0. But if it exists, then we try to traverse its children, and we check as if this node was a root. What would be so root meaning we could split by it. Let's say it like that. So it's root of some subtree. And it's not necessary that we split, but if we have possibility to split, maybe this is the greatest. In example, this was -7, then this would be the greatest. So we split if it makes sense to split, and check if this was root, how much it would be. So here it's 15, and we update our result. So currently best result is, or let's start from here. We have a node, so we traverse left and right. On the left side we have 9. 9 is current best, but we traverse down, so we have none, and that means that our current best is 9. We return 9 to the parent, and this is -1. We return 9 to the parent, but we also do the right subtree. So from the right side subtree perspective, we do 20, but we traverse to again left side. So we do 15. 15 is best, so we update our best. We return 15 to 20 and 7 to 20. They sum up, and if 20 was root, we would give 35, 42. But the only interesting thing is when we put the value, what we return is actually not this as a root, but if we had to split, if we are not able to split in both directions, we have to choose one, we just return the best one, or maybe if this was all negative, we would return 0. So a lot of talking. Let me get to programming. So I'll use result, and it will be root value, because we at least have one node, so I can do it like that. And I'll have a function called find, which will just take a node and check if not node, then I just return 0. Since I have node, I have to check left and right. It's not start, but right. Left is equal find of node dot left. Right is equal find of node dot right. So I have this, and now I need to check if, so I'll call it current, it's node dot value plus left plus right. I'll do it like this, but I'll fix this left and right in a return statement. So this is if the if this node was root node and we had a possibility to split, and if current is greater than result, then I update result. Let's make it here local result. Okay. So we update result if we have found something better, and here we just return. So here we have to return either so max of node value. If it's all negative, then 0, then I don't care. So either node value plus just max of left, right, 0. I guess this is it. So if node was negative, then I would return 0. If both of the children were negative, I would return 0. And if they were positive or whatever, I would choose the bigger one. So I do the find of a node. Just this, and I return result. And this should be it. Node. Oof. Still a mistake. Okay, it works. Let's do quick submit, and it's pretty good. So yeah, not so interesting example, but actually not that hard if you try to think about it a bit more. I'm sorry about that. So as a complexity is time complexity, well, it's off, and we just visit each node once. And space complexity, well, recursion depth will be of a height, but that's worst case off. And again, let's confirm that off, and possible this will also be off, and yeah, so yeah. Okay, hope this was clear. If you have any questions regarding code, leave a comment. I appreciate you for following this video, and see you in the next one.